Okay, let's look at these half-life problems. It's important that we do these because these tend to show up on standardized tests a lot, like the SATs and that kind of thing, because even if you've not been taught half-life, a lot of times you can reason out how it works just by understanding what half-life means. So in the first example, we have an isotope of cesium, and specifically it's cesium-137, has a half-life of 30 years. That means every 30 years, half of the sample decays to a new atom. If 1.0 grams of cesium decays over a period of 90 years, how many grams of cesium-137 would remain? The first thing to do is to find out how many half-lives have happened. We have 90 years. First thing to do is to find out how many half-lives have happened. We have 90 years, and we want to see how many 30 years are in that. So we do 90 divided by 30, gives us 3 half-lives. So now we have our 1 gram. After 1 half-life, we have 0.5 grams, and we just divided it in half. After a second half-life, we have 0.25 grams, and after our third half-life, we have 0.125 grams. So after 90 years, we'd have 0.125 grams left. And the next one says selenium-83 has a half-life of 25 minutes. How many minutes would it take for a 10 milligram sample to decay? How many minutes would it take for a 10 milligram sample to decay and have only 0.625 milligrams remain? So this question is asking the same thing, but in a different way. Still, the first step is to find out how many half-lives have occurred, but instead of knowing how much time, we know how much is left. So we just have to see how many times do we have to divide this in half to get our 0.625. So after 1 half-life, we have 5 milligrams. After a second half-life, we have 2.5. After a third, we have 1.25. And then after the fourth, we would have 0.625. So we know that 4 half-lives have occurred. If each half-life is 25 minutes, and we had 4 of them, then we know 100 minutes have passed.